Hey everybody, welcome to this extra video in assembler language. I'm Bill Sky, the assembly guy, and what we're going to do in this is a request from a subscriber, at least I hope he's a subscriber, or they are a subscriber, to view what does the assembler actually create, what does it actually put into the executable file, and how can we see that. And I'm going to do this on Linux, and then I'm going to do it on Windows. You're going to see how much easier it is on Linux. Windows is a little bit more difficult, but we're going to get there. So let's get right to the demo. All right, so I've got my Linux up and running here. Let's go into my home folder, my documents, and I'm going to go into my assembler projects. And I've got a number of projects here. I can pick any one of these. Let's take a look at the x86 registers demo. I just want to see what code is in there. Yep, there's enough code in there where we can do something. So when you build using my templates in assembler, when you build the project, it creates a file called main.lst, and that's the main listing file for the assembly. So if I go ahead and just double click on that, it actually what it does is it brings up and it shows what all the code was. Now a lot of this is from the include that's in that code, that particular code. What I'm doing is I'm looking for an area that just doesn't have this one number that has hexadecimal values in it. So I'm just going to scroll all the way down because these are all preprocessor directives, so they don't really generate any code. And here we go right here. So this is our data section, and we can take a look at that, but it's going to be pretty obvious in the hexadecimal editor when we look at it. But let's take a look at our text section. That's where our code is actually located. And what you have here is you have the displacement from the beginning of the code section, and then you have the actual machine code. So no-op is a machine code hexadecimal 90. Push open prompt is a 68, and it is 1 byte below the 90. That's what this displacement is. How many bytes below? You can see that the next one, called print string, that is a displacement of 6 from the top. And if you subtract 1 from 6, this statement right here took 5 bytes. That's how big it is. So the actual instruction in memory. So you can actually kind of do some of that. Also, you can see the machine code, and what's really cool about this listing file is that now we can go into the object program, or we can go into the executable, and we can go looking for these machine code statements, find them, and actually see the code. And we can actually modify the code with the hex editor, which is kind of like what hackers do when they put a virus or something into an executable. So maybe I shouldn't show you this, but I'm going to do it anyway. It's not a big secret. So what I'm going to do here is I'm going to move some windows around here, and I'm going to right click on the object file. The .o is the object file. It's not the executable, it's before the link. It's smaller, so I'm going to right click on that, and I'm going to open with other application, and I'm going to go down here, and here's this ghex. Now I have ghex installed, and every assembler coder should have that. If you don't have that installed in your Linux, sudo apt install -y ghex. That's all it takes to install it. Installs it, and everything will be great. Okay, so just right click on that, open with other app. Now I have opened it with ghex before, so I'm going to go ahead and just click on that. And this is the actual hexadecimal code. You could think of it also as binary code in hex, which actually it is. It's binary code. And this is the actual machine code in the object file. Now how can I actually find my code? Well, I'm going to look for the code 9068. 90 is a no-op, 68 is the first instruction after the 90. So I'm going to press Control F, and I'm going to look for 9068 and press enter. And there it is. There's my 9068. So there's the no-op, this 90. Here's the 68. And then here's the 00000E8. That's this one. You can see this B8 FFFF. That's this one right here. Here it is, B8. Now remember, little endian order. B8 FFFFF right there. So the bytes are in reverse order. This one right here is B011. Oh, no, I guess they're not in reverse order. That's cool. G-Hex is doing that for us. So B011, here's B422. So in this particular program, G-Hex, I can actually go in here and change these and ruin the program. So I could put like a no-op, I could put 90. And so I'm basically saying I want this to be a no-op. I don't actually want to move 22 to AH. And that would essentially break the program. And then I could say File, Save. Now, if I don't want to, I'm going to discard that. If I want to look at the executable, because the program is the object file is main.o, but the actual program is here. So I'm going to go to the executable, and I'm going to go find G-Hex. There it is. And I'm going to go looking for the same thing. I'm looking for 9068, so Control F 9068. And did it find it? Yep, there's the 9068. It looks like, yeah, that's a little bit different because I'm looking for an E8. So maybe the linker put some, here's the E8 and here's the E8. So maybe the linker compressed, or maybe it added some more stuff in there. Let's do another search for that. Nope, that's it. So the linker obviously did something with this. I'm not really sure why. I would have to look into it. So that's how you can look at the executed code and look at, you can also see all the other stuff that the linker put in. Look at the size of this thing all linked up, because it also includes all of the operating system libraries necessary. If I open up just the object file, it's nowhere near as big. And you can also look at the list view and just see how big it is. It's 1.9 kilobytes, the main.o, and the executable is 35.9 kilobytes. So it's almost like 32 times bigger than the object file. Not quite that, maybe 16 times bigger. So that is the demo on Linux. So we saw this on Linux. Now let's take a look at it on Windows. If you don't have the Linux subsystem installed, or if you don't have VMware or VirtualBox or Hyper-V and you're not using Linux, first of all, you should, but if you're not yet, let's take a look at it on Visual Studio on Windows. So I have my Visual Studio here, and I have a program open, and I'm going to go ahead and build it. I'm just going to rebuild everything, make sure it builds okay. Now, there is one thing that we need to do, is we need to create a listing file so we can kind of get an idea of what the assembler generated, so we can go search for it like we did in Linux. Also, I have a couple of apps installed here. I have a really nice Notepad, Notepad++. It's a very nice little programmer's editor. It's a lot like Genie on Linux. I would really recommend that you go search for that and download it. Also, HXD. I downloaded the UK version of HXD. It's written by a developer in Europe. It's a great little hex editor. You have to download it and then install it. See, things are a little bit more difficult on Windows, but it's a great hex editor. So I put those two on my desktop so I can actually use them. Now, by default, my templates do not create a listing file. So what you need to do is you need to come over here, Visual Studio. You need to right-click on the project and say Properties. And then you have to come down here to Macro Assembler. You have to expand it, go to Listing File, and on the very last one, you just put main.lst, press OK, and now you want to rebuild your app. So I'm going to click on Build, Rebuild Solution. And now to actually see your listing file, I'm going to right-click on the project, and I'm going to say Open Folder in File Explorer. And now here's my File Explorer, and there's my, where's my main, yep, there it is. Now, Windows doesn't show the .lst because it knows what that is. So it says it's going to open it with Notepad, so I'm just going to double click it. And there's my listing file in Notepad++, and it looks a lot like what it did in Genie on Linux. And there's our 90, and there's a 48. So that's what we can use to go find it in the HXD app. Now I'm going to go into x64, which is where the object files and the executable are. I'm going to double click on debug, and here's the executable. Now the object file, I'm not really sure where it is. Yeah, and I don't see, it's a little bit more difficult on Windows. So I'm just going to use the executable. So I'm going to drag the executable over here to HXD icon, and then HXD opens up, and pretty big executable. And what I'm going to do is I'm going to Control F, and I'm going to click on hex values, and I'm going to look at my listing file, and I'm going to look for 9048. Now the listing file on Windows is almost identical to the listing file on Linux, so it should be pretty easy to read. And I'm going to do a search for 9048 and press enter, and there it is, it found it. So there's our 9048. After 9048 is this E80000. Here's E80000. There's another E80000. Here's E80000. So we're looking at the machine code in the actual executable. And how did we find it? Because we used this listing file. Listing files are really, really useful. Even back before we had debuggers and PCs and we were doing everything on the mainframe, that's what we lived with. We lived with listing files. And yes, I'm that old. Mainframes, no such thing as a PC, and that's how we did things. When we would generate an assembler language program or even a COBOL program or Fortran, we would have it print out a listing file, and we would see all the machine code, and we would use that for debugging. So I hope this little extra video helps you out to kind of see how the source code is related to machine code, which is related to your executable program. Hope to see you at my next video.